Alright, let's have a look at 1356. We have a 5 megagram airplane is flying at a constant speed. Okay, and we know what this is. It's 350 k's an hour along a horizontal circular path. If the banking angle theta equals 15 degrees, determine the uplift force L acting on the airplane and the radius of the circular path. Neglect the size of the airplane. Okay, so let's extract the information. So we know that this plane is just flying in a horizontal path. If you look at it from the top, it's just a circular path. What is the mass? The mass we know is 5,000 kilograms. And the speed is given in kilometers per hour. How do we convert that? Well, we want to get rid of the hour, so we multiply by hour over seconds. How many seconds in an hour? And we want to get rid of the kilometers, so we need to divide by the kilometers, but multiply by the equivalent in meters. And so basically what you notice is if you're trying to convert from kilometers an hour to meters per second, all you really need to do is divide by 3.6. Okay, and this becomes 97.22 meters per second. Okay, so that's important for later on. Now what we want to do is we want to draw our free body diagram. We know that that is our normal direction, that is our binormal direction, and we know that we're going to have mg acting down, and we've got this lift force L acting at 15 degrees. So what's your banking angle? That's your banking angle of 15 degrees, right? And so this angle there is 15, this angle there is 75, and that angle there is 15. Okay, so just make sure you can work the geometry. Okay, so sorry, I need to put an arrow there. So we've got the only two forces acting on the plane is the weight, and R, the weight, and the lift force. So now, what are we trying to find? We're trying to find the lift force, and we're trying to find the radius of curvature. Okay? So, sum of the forces in the, let's just take one, in the binormal, is equal to 0 because it's not moving up or down in this direction, in the binormal direction. We can choose up as positive. Then we've got what? We've got L cos 15 equals mg. That's what we got. And m, mass there, is 5,000, okay? And gravity is 9.81. So if you solve for L, you get 50,780 Newton, or 50.78 kilonewton. Now, so we've done that. We've solved L. Great. Now we want to solve for the radius of curvature. So that is positive. Sum of the forces in the normal direction is mass times velocity squared over the radius. That's what we're trying to find. Okay. Okay, so what are all the forces acting in the normal direction? It's simply going to be L sine 15. So we've got L sine 15 is the mass v squared over rho. Now what is L? We just solved for L, put that in there. What is the mass? That's 5,000. What is the velocity? Well, we calculated it to be 97.22. Plug all that in there and you get a radius of curvature of 3.595 kilometers. Alright, well, at least that's what I got. Okay? Good stuff. See you in the next one.